who are still working on finishing up the mold test, I thought I would make a quick little overview for you. So you have 16 grams of aluminum selenide as an example problem. Remember, your questions are different, but the format is basically the same. So you have 16 moles of aluminum selenide. So you have to write the formula for aluminum selenide, which is aluminum. Selenide, the IDE ending, remember, is the means it's a plain element in most cases. So selenide is right here, selenium, has a -2 charge. See, it's got 6 valence electrons, going to gain 2. Aluminum's got a +3 charge. So you're going to have a +3. Selenium is a -2. 3 and 2 common multiple is 6, so you're going to have 2 of those and 3 of those. Okay, we're looking for grams, so we want to get rid of moles. So you've heard me say a lot of times that whatever unit is here goes on the bottom, so you'd have moles of aluminum selenide on the bottom and grams of aluminum selenide on the top. All right, so 1 always goes in moles on the mole test. And with the aluminum selenide, you got to find the formula mass, and it's hard to see this, I know, but let's get a little higher maybe. See, the aluminum there is 26.98. It's a little blurry, but that's because of this camera I'm using. And selenium is, if you read it, you can't read it on this thing, but if you look on my web page, you'll find a periodic table that you can read. And selenium is 78.96. We're going to call that 79. So if I'm going to write the formula mass of aluminum selenide, I have 2 aluminums, which would be 27 times 2. I have 3 seleniums, which is 79 times 3. Well, 79 times 3 would be kind of like 80 times 3 would be 240, so it would be 237. 27 times 2 is 54. So if you add 54 and 237, you get 11, 8, 9, 291. So that would be 291 grams is 1 mole. So then you would do 16 times 291. So let's pull out a calculator here if I can find one. So 16 multiplied by 291, 4,656. So this answer is 4,656 grams. Okay, your test will be same format. This formula will be different. You got to use this logic that we talked about where you have to consider the charges. +3 minus 2. You got to look up your charges, see what the formula is, and find the formula mass, and that's what goes here. Next one. You're looking for how many molecules are in 320 grams. Grams are over here, molecules over here. So looking at the mole map, you're going to go from grams to moles first, and then moles to molecules. That's different from the first one because in the first one we had grams, and we're trying to get, no, we had moles, and we're trying to get to grams, so you had to go from here to there. 1 step. Here you got 1 step, and then another step, 2 steps. All right, so we have 320 grams of propene. On this one, I told you the formula. It's C3H6. On yours, I might not have told you the formula. I might have given you a name again without a formula, in which case you have to write the formula. All right, so C3H6, and grams of C3H6 are there. Moles of C3H6 on top. 1 goes in moles. We have to find out how many grams are in 1 mole. So you look on your periodic table. Carbon's 12, and hydrogen's just 1. So you got 12 times 3 plus 6 times 1 is 42. Then we need to get rid of moles. See, if we stop the problem right here, we'd be at this point. We need to get over here. So I'm going to put moles on the bottom. Remember, moles and molecules are 2 different things. And then molecules on the top. 1 goes in moles, and the number of molecules are in a mole is this number right here, which I'll go down here and point out. It's that number, 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd. All right, on your calculator, you're going to multiply 320 times 6.02. Then remember, you don't ever type in times 10. You use the EE key. 23. Okay, that equals. And then we're going to divide by everything we see on the bottom, which is just a 42. So final answer there is 4.59 times 10 to the 24th. That E means times 10. So 4.59 times 10 to the 24th. See, grams cancel, moles cancel, you're left with molecules. C3H6. This was C3H6 also. Okay, now we got aluminum sulfate. So you got 936 grams of aluminum sulfate. Grams are here. We want to find moles, so we're going to have one-step problem. You do have to write the formula for aluminum sulfate. On whatever test you have, you will have to write this formula correctly. We've already established that aluminum has a +3 charge. Sulfate you'll find down at the bottom of the periodic table. It's right here. It's SO4 with a -2 charge. So 3 and 2 common multiple. You got to have 2 of those. The 6 is the common multiple, so 2 times 3 makes 6. 3 times 2 makes 6. Okay, and you put grams of aluminum sulfate on the bottom. So whatever's here, except for that number, goes on the bottom. On the top, moles of aluminum sulfate. And what's the number that always goes to moles? 1. Finding the grams here, I would suggest that you do what's in the parentheses first. So you look at sulfur, 32, you got oxygen, 16, sulfur is 32, oxygen 16. And once again, you can see that periodic table. Whoops, I want paper tape. You can see the periodic table by going here and clicking on the website here, and then you can see easily what these numbers are. The sulfur, remember I said it's 32, and oxygen 16. So go back over here. So we have 30, I'm going to put this in parentheses. In the parentheses I have 32 plus 16 times 4. Right here, 32, 16 times 4. And then I've got to add the aluminum. I've got, I take that back. I've got 32 plus 16 times 4. I've got to multiply by 3. Because there are 3 of everything that's in the parentheses. So in the parentheses you get 32, 16 times 4, all that gets multiplied by 3. Then you add the aluminum, which is 27, times 2. And again, I get the 27 from the periodic table. It's right here, 26.98 rounds off to 27. All right, so 16 times 4, go back so you can see what I'm doing. 16 times 4 is 64. Add the 32 makes 96. So really we have 96 inside the parentheses, times 3. So 96 times 3 would be 288. Then you can do that on the calculator. And in 27 times 2 is 54, so it's 288 plus 27 times 2. 288 plus 54. 288 plus 54 equals 342. So this is 342 grams. Now, to do the math, you have 936 times 1 divided by 342. So it would be 936 divided by 342, answer 2.74. And that would be moles, because grams cancel. Okay, once again, it's a one-step problem. Again, you'll have to create your own formula for your compound, whatever it is. Okay, number 4. How many liters are in this many molecules? So it's 2.44 times 10 to the 28th on this test. And it doesn't say what the gas is. So I just put of gas. So molecules are here. We want to get to liters down here. So you're going to go over and then down. 2 steps. So go to moles first. Molecules here. Moles here. 1 mole, 6.02 times 10 to the 23rd molecules. That's this number right here. Another step, step 2. Got to go to liters. Moles on the bottom. Liters on the top. 1 goes in moles. For gases, 1 mole is always 22.4 liters. All right, so let's go ahead and do this math. So you're going to have 2.44 times 10 to the 28th. Notice I hit that EE key, multiplied by 1, which I'm going to skip, multiplied by 22.4. Find final answer there on top, 5.5 times 10 to the 29th. But I still need to divide by everything you see on the bottom. So I'm going to divide by 6.02 EE again for times 10, 23. Final answer, 907,906. And that is liters. So there's a lot of liters. 907,906. Oh, I should say 907, sorry. Because this 6 is followed by a 9 right here, so it should round up to 907. Okay, last question. You want to know the mass of 89.6 liters. So liters are down here. You're trying to find mass, which is over here, grams. So you take your 89.6 liters. Carbon dioxide, again, you'll have to find your formula mass, or your chemical formula, but what's di mean? Di means 2, so carbon with 2 oxygens. Liters here, moles here, 1, 22.4. So we just went from here to there. Now we want to go to mass. So is mass atoms, molecules, formula units, or is mass measured in grams? Well, it's measured in grams, so you're going to go this way. I'm going to go ahead and write down what these are because that's going to become important right now. So moles of CO2 on the bottom, grams of CO2 on top. 1 mole is 44 grams. Now how do I get 44? Carbon is 12 and oxygen is 16. You have 2 oxygens. 16 times 2 is 24. I see it through 32. Plus 12 more makes 44. That's how I got 44. Okay, so this divided 89. I just do the math here real quick. So 89.6 multiplied by 1 times 44, and then divide that by 22.4, and that is equal to 176. All right, so all the tests follow this basic format, and you will have to find your own chemical formulas based on what you have, mole maps on each one, and if you haven't finished that yet, you really need to.